Welcome to this module where we will be talking about the valence electrons and molecules. So first, let's start with valence electrons. The valence electron is the amount of electrons that an atom has in its outermost shell. And so you can tell the way that an atom will behave depending on the number of valence electrons that an atom has, because all atoms want to achieve 8 valence electrons in their outermost shell, and we will talk about that in just a second. But for now, we're going to move on to what is called the periodic table of the elements. You may be familiar with this table, but as you can see, there is a lot of information that we can take from this table. The information that we will be most concerned with is the groups and the periods, which we'll call rows and columns. So rows is what runs from left to right, and columns are what run from top to bottom. So for now, we're going to focus on the first 3 rows, or the first 3 periods, and we're going to focus on groups 1, 2, and then 13 through 18. So we're going to ignore columns 3 through 12, or groups 3 through 12. So the importance of this setup is the column, or the group, tells us how many valence electrons this atom has. So for hydrogen, lithium, and sodium, they all have 1 valence electron. Beryllium and magnesium have 2. And then we're going to hop over and we're going to take the 1 away from 13, 14, 15, 16, and 17, and 18, and that will tell us how many valence electrons they have. So we know that boron and aluminum have 3, and then these two have 4, so on, 5, 6, 7, and 8. Okay, so now that we know that, we're going to practice just a little bit on the next page. On this page, I want you to look over the atoms and where they sit on the periodic table and tell me how many valence electrons each of them have. Okay, so go ahead and pause this video and resume it once you think that you have the answers. Okay, so the answers here, we see that sodium, to Na, sits in the first group, or the first column, and so the amount of valence electrons that it has is 1. Same with carbon, we see it sits in 14, okay? Then oxygen is in 16, chlorine is in 17, and magnesium is back in 2. So there we see that sodium will have 1, carbon is 4, oxygen is 6 valence electrons, chlorine is 7, magnesium has 2. So now that we understand that, we'll talk a little bit about molecular compounds and the octet rule. You'll find that molecules are a lot like humans, and one way that they're a lot like humans is they are most happy when they are most stable. Like I talked about earlier, they want 8 electrons in their valence shell so that they can be most stable. That is as stable as they can get. So in order to get 8, what might happen is 2 different atoms may form a bond, and we call that bond a molecule, where these 2 atoms are going to share their valence electrons, and ideally they're going to share so that both have 8. So we're going to see that maybe an example will be atom with 2 valence electrons will share with one that has 6, and then they'll have 8. So on the next page, I want you to add up these and tell me which one does not add up to 8, or which one is not naturally occurring. And then you can go ahead and rule 1 out, whichever one does not add up to 8, and we'll talk about that in just a second. So pause the video, work on that, and then in a couple seconds, we'll go back to, we'll go to the next slide. All right, so here are the answers. The one that was not naturally occurring was D. We see that sodium would have 1 and chlorine would have 7, so they will bond together and they'll form a compound that has 8. And then same with hydrogen and fluorine, that has 8. Magnesium, oxygen has 8, but